Alright, hey guys. In this video, what we're going to do is we're going to start looking at complex numbers. But first, we need to introduce a new term. The imaginary unit. Alright, the imaginary unit is defined as I is equal to the square root of -1 and I squared is equal to -1. Alright, so what this is going to allow us to do is going to allow us to start working with and taking the square roots of negative numbers. Alright, so for any positive real number, so for any positive real number, we're just going to say b. Okay, so for any real positive number b, if I'm trying to take the square root of that number, well, I can do that now as long as I take this negative, pull it out, it becomes an I, and then I have the square root of b. Okay, so we're going to use this rule in dealing with the square roots of negative numbers. All right, so for instance, let's say we want to take the square root of -64. All right, well, last time we looked at this, we had to say that it's not a real number. Okay, there's nothing we can do. But now that we have defined I, we can do something with this. So according to this rule, before you can do anything with that, you must first get rid of this negative on the inside. Well, to do that, you just pull it out, and when you do, it becomes an I. So now we have the I times the square root of 64. Well, the square root of 64, we know by now, is just 8, so we're left with 8i. So the square root of -64 is 8i. All right, let's look at one more. So I want to take the negative square root of -144. All right, again, before I can do anything with this, I must get rid of the negative on the inside. So I pull it out, so I have negative I square root of positive 144 now. Well, the square root of positive 144, we know it's just 12, so I have negative I times 12. Multiply all that together, we get negative 12i. Remember, it's okay to have the negative on the outside, just not on the inside. Okay, so now that we can work with negative numbers and take negative square roots, it's going to lead us to using and working with complex numbers. All right, so now we're going to introduce a whole new set of numbers called the complex numbers. All right, so complex numbers are written in the form of a plus bi, where this a, that's our real part. Okay, that's our real part. And over here, we have our imaginary part. Okay, so with complex numbers, we have a real part and we have an imaginary part. So what we're going to be focused on here is adding and subtracting complex numbers and then multiplying and dividing. All right, so let's look at adding and subtracting first. So let's say we want to add 7 minus I plus -9 plus 3i. All right, so if you notice, both of these are in the form of a complex number. So all we have to do in order to add these is just to add our real parts together and to add our imaginary parts together. Our answers should look in this form here. They should look like a real part plus an imaginary part. All right, so if I take my real parts together, I have 7 plus -9. That gives me -2. If I take my imaginary parts, -i plus 3, well, that's plus 2i. And there's our answer there. Okay, so anytime you add or subtract, you just add or subtract the real parts, add or subtract the imaginary parts. All right, so let's look at another. All right, so here we have subtraction. Remember, just like any problem dealing with subtraction, we must distribute that subtraction sign through our problem. So my first one stays the same, -4 plus 4i. Now this is minus 12 plus 13i. Distribute that through. Now my real part, -4 minus 12 is -16. 4i plus 13, that gives me 17i. So my answer is -16 plus 17i. All right, very good. So adding and subtracting are pretty easy. Just like adding and subtracting any numbers, you just have to combine your like terms. Combine your real parts together, combine your imaginary parts together. All right, so now let's look at multiplying complex numbers. All right, so here we have 3 minus 4i times 8 plus i. All right, well, if you notice, we have two binomials, and so to multiply those, we're going to forward. So I have first times first, so that's positive 24. Outer, 3 times I, is plus 3i. Inner, negative 4i times 8 is minus 32i. And then last, we get negative 4i times I is negative 4i squared. Combine like terms, so I keep my 24. 3i minus 32i, well, that's negative 29i. Minus 4, well, remember what we said in the beginning. I equals the square root of negative 1, so I squared equals negative 1. So what we're going to have to do is everywhere we always see an I squared, we have to plug in the negative 1. So this is 4 times negative 1. So this is 24 minus 29i plus now 4. Combine our like terms, 24 plus 4, we get 29 minus 29i. All right, and remember, your answer needs to be written in this standard form. Your real part plus your imaginary part. All right? So now I want you guys to try one. I want you to multiply. All right, so pause the video. Give yourself a couple of minutes to solve this. Come back and we'll look at it and see how well you did. All right, guys, so now let's look and see how you did. So 4 plus 8i squared, well, what that means is we have 4 plus 8i times 4 plus 8i. Again, fold it out. 4 times 4 is 16 plus 32i plus 32i plus 64i squared. Combine like terms. 16 plus 64i. Now remember, I squared, that's negative 1. So I'm going to replace this I squared with negative 1. So now that becomes minus 64. 16 minus 64 is negative 48 plus 64i. And again, there's our answer in our standard form of a complex number. All right, so again, multiplying is not bad. It's just like multiplying regular. The only difference is everywhere we see an I squared, we have to make sure we don't forget to plug in negative 1. All right, good. Now the tough part is let's look at dividing complex numbers. All right, so before we get really into dividing, I want us to look at a concept which are complex conjugates. All right, complex conjugates, or conjugates of complex numbers, however you want to say it. All right, well, what these are, what the conjugates are, is a plus bi times a minus bi. So they're like opposites of each other. But anytime we have that, what that does is that simplifies into a squared plus b squared. Okay, so what this does is gets rid of our i's completely. Okay, so we're going to have to use this method when dividing complex numbers. All right, so let's look at an example. Say we want to divide 2 over 1 minus I. All right. Well, if we remember what I is, remember I is really equal to the square root of negative 1. We cannot have that on the bottom of a fraction. Okay, it's kind of like a 0. You can't have that square root of a negative number on the bottom of a fraction. So what we have to do is what we call rationalizing the denominator. We have to be able to get rid of that off the bottom of the fraction. And the way we do that is by using the conjugate of our complex number. Remember, the conjugate of 1 minus I would be 1 plus I. So I'm going to multiply the bottom by that 1 plus I. But remember, whatever we do to one, we have to do to the other. So I'm also going to multiply the top by that 1 plus I. And now we just multiply across. So this is 2 times 1 plus I over 1 minus I, 1 plus I. Well, the top is just 2 times 1 is 2. 2 times I is 2I. All right? And the bottom, okay, the bottom we know, if you multiply conjugates, it's the first term squared. So 1 squared is 1 plus the coefficient of the I, which in this case is also 1. So it's 1 plus 1, which simplifies to 2. All right. Well, now what we can do is we can factor the top out. Each term up here has a 2 in common. So that's 2 times 1 plus I over 2. I can cancel my 2's out, and I'm left with 1 plus I. Right. So again, you have to make sure when you simplify completely and that you can't go any further. All right, let's look at a different one. Again, we're still dividing. We have 5i over 4 plus 4i. All right, again, we got to get rid of that I on the bottom. So to do that, we're going to multiply by the conjugate. So that's 5i, the conjugate, that's 4 minus 4i. So we have to multiply the top by 4 minus 4i as well. So now the top, that gives me 5i times 4 minus 4i over, remember it's 4 squared plus the conjugate of the coefficient, which is also 4 squared. Now let's simplify this up. 5i times 4, that's 20i. 5i times negative 4, well that's minus 20i squared, over 16 plus 16. I see an I squared, I had to plug in negative 1. So this is 20i minus 20 times negative 1 over 16 plus 16 is 32. All right, so let's keep going. Well, this right here, negative 20 times negative 1 gives me a positive 20. So that's positive 20 plus 20i over 32. Everything looks like it has a 2 in common, so I'm going to factor that out first. All right, but if we notice, it has more than a 2. They all have a 4 in common. Let's factor 4 out first. So that's 4. That leaves me with 5 plus 5i over 8. Again, I can reduce my 4 over 8 by 4. So that leaves me with 5 plus 5i over 4. But remember, that's not standard form. Standard form is we have a real part plus an imaginary part. So once we get here, once we get to this part, we need to split it up into our real plus our imaginary. So just break it apart. So you have 4 over 5 plus, you have 5 over 4 plus 5 over 4i. All right, so you must split your final answer up to where it is in our standard form. All right, so make sure you practice these. If you have any questions, just let me know and we'll work some more out together. Thank you.